You've probably heard of stem cells and their ability to transform from undifferentiated or non-specialized cells into fully mature cells such as neurons or muscle cells. As you might know, these cells are really important to regenerative medicine because they have the ability to repair damaged tissues, and they even have the potential to be grown into fully formed tissues themselves. But stem cells have another major use that is now being investigated as a breakthrough in regenerative medicine. Stem cell conditioned media, or the secretosome of stem cells, is a biologically active compound that has now been known to treat disease manifestations in murine models. Stem cell conditioned media, or CDM for short, is made using varied protocols, but they all follow the same general method. Let's take a look. First, stem cells must be harvested from a tissue source and grown at a relatively high density, somewhere around 110,000 cells per centimeter squared. Stem cells can come from many different places, including bone marrow, dental pulp, and adipose tissue. The stem cells are placed in a serum-free growth media, which is media that's been processed to make sure that there are no inhibitors or growth factors inside of it. And the stem cells are allowed to condition the media or secrete the contents of the cell for varied amounts of time, ranging anywhere from 24 hours to several days. This time frame depends upon the type of stem cell used and the type of conditioned media that's being created. Then the stem cell is put inside a centrifuge which spins it continuously, making sure that there are no cells remaining. There you have it, conditioned media. Right about now you're probably asking, what are we supposed to do with this? Well, you astute science student, there are many different ways that conditioned media is administered. In Dr. Hansman's study of CDM's effect on rat pups with lung injury, subjects were given intravenous injections of conditioned media, but it can also be delivered intranasally or ingested. The studies of lung disease, such as bronchopulmonary dysplasia, have shown us that conditioned media can work comparably to stem cells. We still don't know exactly what it is in conditioned media that makes it work so well. We know that conditioned media contains the sugars and amino acids from the petri dish that the stem cells were grown in, and we know that the stem cells secrete cytokines, chemokines, immunomodulatory molecules, and growth factor. But we don't know if that's all that the stem cells secrete, and we don't know which of those is the most significant in producing these results. Therefore, continued research is being done to specialize conditioned media treatment so that we can maximize its benefits. This research is really important because conditioned media is more easily translated to the clinical setting than stem cell research is. Conditioned media is more easily accepted by the recipient of the treatment, it has a lower risk of infection, and it's more easily stored for the clinical setting. That's why we need more researchers just like you to investigate this intriguing treatment.